All right. Welcome again to the second part of our example, whereby we are solving, we are expressing, or we are representing the function f of x is equals to x minus x squared, and x lies between negative pi and pi. Remember, we had already obtained the value. We had already obtained the value of a naught. We had already obtained the value of a naught over 2. We had already obtained the value of a naught over 2, whereby we said that we obtained it as negative pi squared over 3. We obtained the value of a naught over 2 as negative pi squared over 3. So now I want us to proceed together and obtain the value of n, the value of an. And we said that a sub n, is given by 1 over pi. It's given by 1 over pi. The integral, of course, we are already given the interval. The interval is given from negative pi to pi. So that is what we are going to use. So it will be from negative pi to pi. Then f of x, cosine of f of x, the cosine of n, x dx. And then of course, because we already have our question, our function f of x, we now substitute x minus x squared. That means here we are going to use to put x minus x squared. So therefore our an will simply be equal to, 1 over pi, the integral from negative pi to pi, x minus x squared into cos nx dx. So now from there we obtain the integral of x minus x squared cosine nx dx to this given interval. So when you look at this kind of integration, remember we have two terms, or we have two parts. We have the part with x minus x squared, and we have the part from where we have the cosine of nx dx. So therefore this tells you that we are going to use a method called integration by parts method, whereby we apply this method uv minus the integral of v du. We apply this method uv minus the integral of v du. Now let's come back to our solution, or our question. So the first thing you do for us to integrate this function without wasting time, I'm going to teach you a simple method of integrating by parts directly without having to repeat all the steps that we have to repeat a step after every step. So the first thing, we are going to let this part, our first part to be u. I'm going to let this first part to be u. Then our second part, from where we have the cosine up to where we have the dx, I'm going to let that part to be our dv. I'm going to let that part to be our dv. Then now we proceed. An will now be equal to 1 over pi. N will be equal to 1 over pi. You can use those brackets. And so the first thing we're going to begin with, we're going to begin by writing the value of u here, which is x minus x squared. We write the value of u here, it is x minus x squared. Then now, because remember we are supposed to have uv. Remember, you're supposed to have uv, therefore, and we have dv here. We have dv here, but we are supposed to write, this is our u, we're supposed to write uv. So we are going to obtain v from this, our dv, and we are going to obtain v by integrating the cosine nx with respect to x. And once you integrate cosine nx, you are going to get positive 1 over n sine nx. So I'm going to multiply with the 1 over n sine, 1 over n sine nx, 1 over n sine nx. And because we have subtraction here, I'm going to put our subtraction there. Then now you come back here, you come back to this, the whole of this part here. So what you do, we shall be differentiating this part, x minus x squared, as integrating this other part. So we shall be differentiating this part while integrating this part. So let us begin by differentiating this part, x minus x squared. So we are going to get 1 minus 2x. I'm going to get 1 minus 2x, then we multiply with, we now integrate this part, 1 over n sine nx. We integrate this part with respect to x, and we are going to have, when we integrate sine nx, we are going to get negative 1 over n cosine x. So I'm going to have to get negative 1 over n. But because we still have another 1 over n here, so it will be 1 over n squared, then cosine nx, Then once you are through with that, you come here again. You come here from where we have 1 minus 2x to where we have cosine nx. So what we are going to do, we will differentiate again this part. We will differentiate this part from here to here, the part 1 minus 2x, the term 1 minus 2x. We shall differentiate it with respect to x and integrate this part from where we have negative 1 over n squared cosine nx with respect to x. So we differentiate this as we integrate this. So still we put our subtraction there. This is our subtraction we are following. So we put our subtraction there. Once we differentiate this with respect to x, we get negative 2. Once we differentiate this term with respect to s, we get negative 2. Then we are going to multiply with the integration of negative 1 over n squared, the cosine of nx. And when we integrate cosine nx, we get positive 1 over n sine nx. And because we have negative here, and because we have negative here, we are going to move with our negative. Therefore, we are going to have negative 1 over n. So that is negative 1 over n sine nx. Remember, this is the negative which is here. Now, because we have n squared here, once we multiply 1 over n squared with 1 over n, we are going to get 1 over n cubed. Then now we put our sign. It will be sine nx. It will be sine nx. And then remember that we are working with our limits, negative pi. We are working with our limits, negative pi to the pi. Negative pi to pi. Negative pi to pi. Then from there we are going to, and sorry, before we proceed, when you look at this, our third part, if you differentiate this one as you integrate this one, once you differentiate this one, because this one does not have any x, then it means it is a constant. Therefore, once you differentiate a constant with respect to x, you will get 0. And therefore, for this case, the differential value of negative 2 with respect to x will be 0. And 0 multiplied by any other another thing will give us, or another value will give us 0. That's why our integration ends to that point, or ends at that point. Now we can simplify this. So we're going to have an, or a sub n, being equal to 1 over pi, a sub n being equal to 1 over pi. This will be 1 over n into x minus x squared, 1 over n into x minus x squared, then sine nx minus, remember, minus times minus, or the product of two minuses will give us positive. So it will be plus 1 minus 2x. It will be plus 1 minus 2x. 1 over, sorry, this one should have come before here, but there's no problem, we can write it there. It will be 1 over n squared. 1 over n squared. The cosine of nx, the cosine of nx, the cosine of nx. Then here we have negative, and negative will give us positive. Then the positive with the negative will give us negative. Yeah, so this will be negative 1 over n cubed. This will be negative 1 over n cubed sine of nx, sine of nx, like that. Then we still put our interval. Then from there, we are proceeding well. From there, there is an identity. There is an identity which says that f of x, any function, I'm using f of x to mean any function. So any function times sine nx, any function times sine x is equal to 0. This one is an identity which is supposed to be at your fingertips, that f of x, or any function, times the sine of nx gives us 0. Therefore, any part with the sine will cancel to 0 in this case. So this will cancel to 0 because it has sine nx, and this other one here, will also cancel to 0 because there is sine x. Then we are going to remain with an is equals to 1 over pi into 1 minus 2x. 1 minus 2x, this is 1 over n squared. 1 over n squared, that is 1 over n squared, cos nx, cos nx, cos nx. Still we put our interval. This is pi negative pi. Then we are going to open these brackets so that now our an becomes 1 over pi, or n becomes 1 over pi into, this times 1 will be 1 over n squared, cos nx. We minus this one times this one will be negative 2x over n squared. It will be minus 2x over n squared cos nx. We still have our intervals, that is pi negative pi. We move on. Then now we are going to substitute our limits. We are going to begin by substituting the upper limit, that is our pi, where there is x. Then we shall subtract the substitution of negative pi, where there is x also. So I'm going to have an is equals to 1 over pi into 1 over n squared into 1 over n squared, 1 over n squared cos n pi, minus 2 pi over n squared cos n pi, okay, cos n pi, minus 1 over n squared minus 1 over n squared cos n pi, then minus 2 pi over minus 2 pi over n squared. This is cos n pi, like that. And then of course we have an identity which says that the cosine of n times negative pi, the cosine of n times negative pi is the same as the cosine n pi. So that's why I'm not that's why you are not seeing cosine of negative n pi in this case, because the cosine of n times negative pi is equivalent to the cosine of n pi. This one is also an identity. This one is an identity. Then now from there we will simplify. I'm going to simplify. This one will cancel with that. That one will cancel with that. Then we are going to remain with negative 2 pi over n squared cos n pi and negative 2 pi over n squared cos n pi. So there are two. We have 2 negative 2 pi over n squared cos n pi. So therefore our n will now be equal to 1 over pi, negative 4 pi, because they are 2. You multiply 1 by 2 because they are 2, or you add them, you will get negative 4 pi over n squared, negative 4 pi over n squared cos n pi, like that. So when you simplify, pi will cancel with the pi, and then we are going to have, I'm going to get negative 4 over, I'm going to get negative 4 divided by n squared cos n pi. But remember, or maybe you can know that this one is an identity. You cannot just that this one is an identity. Cos n pi is usually equivalent to negative 1 to the power of n. This one is an identity, and therefore we are going to substitute where there is cos n pi. We will substitute negative 1 to the power of n, and therefore our an will be equal to negative 4 over n squared, negative 4 over n squared into negative 1 to the power of n, negative 4 over n squared to the negative 4 over n squared into negative 1 to the power of n, which is the value of cos n pi. So this is the value of an that we also need in our function. So thank you so much for watching. In our next lesson, we are going to obtain bn. We are going to obtain bn of the remaining part, or that is, we are going to obtain bn. Then after which we shall substitute in our general form of the Fourier series representation of the example that we are doing. So please subscribe and please share. Thank you.